Hello everyone, my name is Diego Rodriguez and today I will be going over Lab 1 on physics, its constant velocity. So this is the table of contents, this is what I will be going over today. So for the introduction, the purpose of this lab is to compare the observed position of an object traveling at a constant speed, in this case we chose a marker, to the predicted position calculated from a computational model. We used GlobeScript. The observed position is obtained with tracker, and the lab will demonstrate Newton's second law. So Newton's second law, the net external force equals the change in momentum of a system divided by the time over which it changes. So basically, if we take that equation, the top one, and we take it forward and derive it, we get the velocity update formula in the bottom. So what did we do? First, we slid a marker across a table and recorded a video of it. Then we imported the video into Tracker and tracked the marker's position frame by frame. And then we created a computational model of the marker's predicted position in GlobeScript by editing a standard code. Then we generated a spreadsheet of the observed and predicted positions, and we graphed the data over time. Then we graphically compared both models side by side, and we made conclusions. So this is Tracker. The red dots you see are me clicking each position frame by frame to track the marker and its position over time. And on the top right, you can see the graph it produced. As you can see, it looks linear, but in reality, it's not because of the external forces acting on the marker, like friction and air resistance. So the tracker analysis, basically, what we did is we got the initial time, the final time, and we got the total time it took the marker to travel across 1 meter. It was 2.10 seconds. Then we took the initial position at time equals 0 and the final position at time equals 2.10. And with that, we can take the velocity and it will give us negative 0.4609 meters per second in vector form. So the computational model GlobeScript, here are some of the most important things we had to change in the code. The time, we had to set it to 2.10 seconds, which is the final time. And the velocity vector, we had to change it to negative 0.4609, which is the number on the slide before for the velocity, average velocity. So this is the observed versus predicted graph. The orange function you can see is the graph we got from Tracker, which looks linear, but it slightly deviates from the fully linear graph we got from the computational model. So the gray line is the computational model function we got from GlobeScript. So some possible errors in our lab are like outside forces, the friction on the table, or air resistance might affect the velocity of our marker. Possible rounding errors during our calculations might slightly deviate our results. The precision tracking, the tracking was done by hand in Tracker, so there might be slight mistakes. Thank you for watching. I hope you have a great day.